All right, welcome development team. Let's jump right into it. Today, we're setting the foundational blueprint for how we're going to deploy multi-agent ecosystems across the enterprise. Look, this explainer isn't about just spinning up another basic chatbot. We are acting as systems architects today, building robust, scalable workflows that can autonomously execute really complex tasks. So get ready, because we are architecting something truly enterprise-grade.
Okay, let's dive into this. On one side, you've got legacy automation. You know the drill. It's built on these incredibly brittle if-then rules. The second it hits an unexpected input, boom, the whole process stalls out and just sits there waiting for a human to unstick it. Contrast that with agentic workflows, which are a total game changer. We're talking adaptive reasoning, continuous learning, and actual end-to-end autonomous execution. Instead of blindly following a rigid script, these agents reason through a problem, pull in external data, and adapt on the fly when conditions change.
So, here is our flight plan for today. We're going to build this mental schematic from the bottom up, covering the core loop, memory and state, orchestration patterns, data and security, testing with human in the loop, and finally how we safely scale all of this into production.
Section 1. The Observe, Think, Act loop.
You really need to think of this loop as the core nervous system of any autonomous agent we build. If you don't have a rock-solid loop here, honestly, nothing else matters. It breaks down into 3 absolutely crucial steps. First, observe. The agent is constantly gathering real-time state data from its environment. Second, think. It analyzes that data and drafts a plan. But here's the kicker. It doesn't freeze up waiting for perfection. Third, act. It executes the action at the lowest stakes level possible and then surfaces the results. We have to build this think versus do mental model right into the agent's identity. A paralyzed agent is completely useless to us. When it's uncertain, it should definitely think and prepare, but it has to default to action to keep the workflow moving.
Moving right along to Section 2, Memory Layers and State Management.
Look, an agent without memory is just going to repeat the exact same mistakes over and over again. To prevent that, we use 3 distinct memory tiers, all tied into a unified knowledge graph. Short-term context handles what's happening right now in the current session. Long-term persistence is what lets the agent recall cross-platform knowledge across multiple sessions. And then you have episodic logs, which track the exact sequence of actions. Let me tell you, that is an absolute lifesaver for debugging. By bridging all these fragmented data silos into one unified graph, our agents can maintain context across completely disparate enterprise systems and do it with sub-millisecond read times. It's pretty amazing.
Section 3. Multi-agent orchestration patterns.
As workflow complexity scales up, we simply can't rely on just one single agent to do everything. We have to transition to coordinating a whole team of specialists. The Collab Tool Builder workflow illustrates this beautifully. You've got a coach, a coder, a critic, and a capitalizer. And they aren't just working in isolated silos, they are iteratively refining outputs together through these continuous micro and macro feedback loops. The coach suggests an approach, the coder writes it, the critic evaluates it, and the capitalizer registers the function. It's a perfect example of specialized agents collaborating to solve a complex problem way better than one giant monolithic agent ever could.
Now, when deploying these teams, we generally use 2 primary patterns. The sequential pattern is highly linear and predictable. Agent A finishes, hands off to Agent B. It's fantastic for tasks requiring strict, step-by-step accuracy, like reviewing a legal contract. But it carries the risk of compounding errors if an early step fails. On the flip side, we have the concurrent pattern. This is where agents process independent tasks in parallel. It gives us massive, high-throughput capabilities for enterprise environments, but it absolutely requires us to build strict conflict resolution rules to aggregate all their findings cleanly. So you've got to choose carefully based on the use case. Are we prioritizing raw speed or strict sequential accuracy?
To actually manage those patterns, we implement what's called a router agent. Think of the router as our triage orchestrator. It doesn't actually do the heavy lifting itself. Instead, it acts as an intelligent dispatcher, dynamically delegating tasks to the right specialist agents based on the runtime context and what the user actually wants. Nailing this implementation is exactly how we avoid those dreaded infinite handoff loops. It ensures a billing issue goes straight to the billing agent and a tech support issue goes to the tech support agent.
All right, Section 4. Data Integration and Security.
This brings us to the fundamental question of the infrastructure layer. How do we feed our agents the live data they actually need to be useful without accidentally leaking sensitive enterprise data? Well, check out this number. 2 million plus. We gave our agents access to over 2 million rows of raw transactions CSVs. We are moving way beyond having AI just write summaries. By handing them raw data, our agents function as true analysts. They can literally calculate margins across supplier categories over a whole quarter without you needing to do any of the initial lookups.
But keep in mind, raw data comes in a lot of different forms. We can take unstructured meeting audio, run it through NLP classification, and output structured agent-ready CRM signals. We take live support tickets, use our agentic routing, and achieve fully automated issue resolution. We can even filter internal comms on Slack or Teams to build out that unified context graph we talked about earlier. We are taking the messy, unstructured reality of daily operations and transforming it directly into actionable, structured data.
Of course, with that kind of data access comes some serious security responsibility. We implement role-based access controls, or RBAC, via agent cards. We enforce mandatory OAuth 2 and mutual TLS authentication across the board. We use dynamic, field-level redaction policies to automatically mask PII, and we maintain protected, completely immutable audit logs. Let me be absolutely clear about this. RBAC and dynamic redaction are not just administrative hurdles. They are strict, non-negotiable engineering requirements for limiting sensitive data exposure in high-stakes environments. Section 5. Testing and Human Oversight, also known as Human in the Loop.
Now, what's really interesting here is how we frame governance. We have to design it not as a roadblock, but as a critical failsafe. I absolutely love this quote, the 90-10 rule. The AI stack handles 90% of the production. You provide the final 10% of elite human judgment. In a properly designed human-in-the-loop system, the AI does all the heavy lifting, gathering data, reasoning, drafting. But for high-stakes environments, we intentionally design checkpoints that concentrate our human oversight exactly where it matters most, like right before an irreversible action is executed.
One of my favorite ways to implement this is through a Devil's Advocate agent. This is a standalone adversarial tool that gets triggered right before any irreversible decisions or high-stakes external communications happen. Its one and only job is to catch those sounds right but is actually completely wrong failure modes. Just adding this one extra automated round trip to the workflow drastically reduces our overall risk profile.
We also have to handle system failures gracefully when they inevitably happen. Check out this error escalation ladder. Step 1. When an API fails or an error happens once, just log it quietly. Step 2. If that exact same error happens 3 times in 7 days, okay, now surface it to the user. Step 3. If it happens 5 times, the system shouldn't just send a notification, it should actually propose a coded solution. We need our systems to intelligently manage API failures. We absolutely cannot bombard our dev team with alert fatigue or trigger some massive PagerDuty alarm at 3 a.m. for a minor hiccup.
And we must rigorously test our edge cases. For instance, we treat all mobile inputs as untrusted right out of the gate to mitigate prompt injection risks. We design fast, cache data paths versus slow API data paths because infrastructure latency must never, ever block the agent's core functionality. We also deploy comprehensive regression test suites for every single configuration update, and we run quarterly system audits using entirely different alternate LLMs to catch any blind spots. That is how you handle malformed data and guarantee system robustness.
Finally, Section 6, Scaling to Production Ecosystems.
So how do we take these isolated pilots and scale them up into a full, interconnected enterprise mesh? This is our phased rollout blueprint. Weeks 1 to 3, we assess the workflows and select our initial agents. Weeks 4 to 7, we set up the core framework and design the routing logic. Weeks 8 to 10, that's when we integrate memory and link our context across the various systems. Weeks 11 to 14 are totally dedicated to brutal edge case testing and optimization. And finally, we move into ongoing governance and the actual production rollout. We're moving systematically from one single, safe pilot straight into a robust, fully governed ecosystem.
I want to leave you all with one final, provocative thought. Think about this. When your entire organization's workflow is automated, how do you ensure the system's encoded knowledge continues to evolve rather than just stagnating? The true power of an agentic workflow isn't merely about automating tasks. It's about building a system where trust compounds over time, continuously learning and self-improving as it goes. Think about how we can build that evolving knowledge base into our architecture starting today. Thanks for joining this explainer. Let's get to work.